7, we looked at properties of exponents. So we're going to do some examples so you can see what that looks like. Parts of the equation, when you have the exponent is the little letter or number. So here's the exponent. And then the big letter or number is called the base. And we learned a bunch of rules, such as the product rule. If they have the same base, you're going to add the exponents. So for example, A, we have 11 A's and we have 4 A's. So we add the exponents, we would have 15 A's. We look at the B's right here. We have 1 B and 6 B's. We have 7 B's. And 3 and 7 are different bases, but they're numbers, so we can multiply them. 3 times 7 is 21. So if we were to simplify that, we would get 21, a to the 15th, b to the 7th. The quotient rule, same base, think about canceling the ones. Let's look at the numbers first. 12 divided by 6 is 2. And then you have 7 A's on top and 3 on bottom. So when you cancel, you have 4 A's left on top. Then you have 1 B on top and 5 B's on the bottom. So when you cancel, you have 4 B's left on the bottom. So think about canceling things that are the same, how many are left and where are they. The negative exponent rule, we did an investigation and we noticed that you can flip them and make them positive. So it's k to the negative 3. This is the same as 1 over k to the 3. Likewise, if we have 1 over m to the negative 5, that's the same as m to the 5 if you move it to the top. We learned that anything to the 0 power is 1. If you distribute this right here, we get a to the 0, b to the 0. We multiply 7 times 0, 8 times 0, which is still 1. So anything to the 0 power is 1. It's the 0 exponent rule. And then the last rule here, power to a power, you distribute the exponent and multiply. So this is a to the 3rd power, b to the 15th, c to the 30th. So let's just do some examples here. So here we have, if we distribute negative 5 squared, x squared, y squared, if we distribute the 2, which gives us 25x squared, y squared. For the next one, we distribute the negative 3, we get t to the negative 30. If we want to write that as a positive exponent, that's the same as 1 over t to the 30th power. Okay, let's try a few more examples here. So the next one, we have 9 B's and another B and another 5 B's. So you're going to add up all the B's together, and this will be b to the 15th. Here we have a to the 3rd, b to the 3rd, and it's negative. Here's what it means. And I write it out like this because you can see we have a negative times a negative, which is a positive, and a positive times a negative, which is negative. And then you distribute the 3 to both the top and the bottom. So we have a to the 3rd, b to the 3rd. The next one, we have 1 over x to the 5th times x to the 8th over 1. And we go straight across here. So we have x to the 8th over x to the 5th. So again, you're going to multiply straight across. And we get x to the 8th over x to the 5th. So that one, when we cancel now, we have 8 x's on top and 5 on bottom. So when you cancel, you have 3 x's left on top. So the first step was to multiply straight across. 1 times x to the 8th is x to the 8th. X to the 5th times 1 is x to the 5th. And then 8 minus 5 is 3. The next one, first step, distribute the 0. And so we have c to the 0 over c to the 0, which is 1. And then you have a negative right here, so we're going to put our negative with the 1. So again, distribute the 0. Anything to the 0 power is 1. And then you have the negative, so we're going to make this a negative 1. Okay, we have, looks like 4 more examples, and then we'll look at finding a common base here. All right, so for this one right here, distribute, we have 4 to the 5th power, g to the 15th, 3 times 5 is 15. And 4 to the 5th, we can actually calculate that. So I'm going to type in my calculator 4 to the 5th power. All right, let me show you this. 4 to the 5th. All right, so 4 to the 5th is 1024. And then we have g to the 15th. For the next one, we have 25 divided by 5 is 5. We have 1x on top, we have 8 x's on bottom. So when you cancel, you have 7 x's on the bottom. We have 11 y's on top and 1 y on bottom. So when you cancel, you have 10 y's on the top. The next one, we distribute this negative 3 right here. We get 4 to the negative 3, x to the negative 15. We're going to flip those to the bottom, and I'm going to do 4 to the 3rd power. So 4 to the 3rd power is 64, x to the 15th. And the last one, we have negative 5 to the 3rd power, g to the 3rd power. Negative 5 to the 3rd power, if we put that in parentheses, would be negative 125, g to the 3rd. So those are just some examples. You can watch the podcast in Chapter 7 to see more. The last thing that we did in this chapter is finding a common base. We know that if the bases match, you can ignore them and set the exponents equal. We have 2 times x minus 1 equals 50. And then we're going to solve. So here we could divide each side by 2. We get x minus 1 equals 25. You can add 1 to each side. So here x equals 26. You can check your answer. 26 minus 1 is 25. 25 times 2 is 50. If they don't have a common base, you have to make them match. So here a common base of 3 and 9 would be 3. So we have 3 to the x plus 10 equals, and 9 is the same as 3 squared. And then you have the x plus 1. So here's what it looks like. Now the bases match, you ignore them. Set the exponents equal. X plus 10 equals 2, x plus 1. We'll distribute. We have x plus 10 equals 2x plus 2. We'll finish solving this. Let's get x on one side, so we're going to subtract x from each side. We get 10 equals x plus 2. Subtract 2 from each side. So here x equals 8. So again, you get a common base. You might have to change the way it looks. If you have this 2 right here, you have to distribute it, and then you can solve. So let's review the different bases and then try a few more. So base 2, here's what it looks like. 2 to the 1st power is 2. 2 squared is 4. 2 to the 3rd means 2 times 2 times 2, which is 8. To the 4th means 2 times 2 times 2 times 2, which is 16. 3 to the 1st is 3. This is 9. This is 27. And 3 to the 4th is 81. Let's take a look at base 4 numbers. 4 to the 1st is 4. We got 16. 4 to the 3rd power is 64. Base 5, this is 5, 25, and 125. Okay, so let's practice finding a common base. If they have a common base, you just set them equal. So we have 3, cross off this, 3x equals 9. Divide by 3. I stopped working there. So here x equals 3. Same thing here, the 3's are common base. So we have x divided by 3 plus 5 equals 6. We're going to subtract 5 from each side. X over 3 equals 1. How do we get rid of divided by 3? We're going to multiply by 3. So here x equals 3. If they don't have a common base, you need to find a common base to make them equal. So for example, we have 2 to the x. If we look at for 32 on the other page here, it'd be the next one, 2 to the 5th, which I didn't go over. So this is 2 to the 5th. Now the bases match, x equals 5. 16 is 2 to the 4th. Ignore your bases. We have 4 equals x plus 1. We'll subtract 1 from each side. We have x equals 3. The next one, we have 3. This would be a base 3, so this is 3 squared times x plus 1. And I think this is the one that we just did. I'll do it again. So this would be 3 to the x plus 3. Cancel your bases, make an equation. We have x plus 3 equals 2 times x plus 1. And then you solve, so you're going to distribute. So we have x plus 3 equals 2x plus 2. And we'll solve this for x. Minus x from each side. We have 3 equals x plus 2. We'll subtract 2 from each side. We have x equals 1. And the last one, I'm going to clear this. Let's give myself more room too. So if you have anything equal to 1, remember that property that this would be 5 to the 0 power. So here's what it looks like. So 3x minus 2 equals 0 if we cancel the 5's. We'll add 2 to each side. We get 3x equals 2. And the last step, divide by 3. So again, if you have exponents, you want to get the basis to match, and then you can set the exponents equal and solve.